Hey everybody, in this video I'm going to answer more of your questions about my 40-foot backyard well. You should use PEX next time. PEX is better and cheaper. No. Okay, one of the most common questions I get is, I thought that shallow well pumps could only pump up to 25 feet. My well point is 40 feet below ground, so you might think shallow well pump, 40 feet is bigger than 25, and so you can't use a shallow well pump. That's not exactly true. My water table is only about 10 feet below the surface, and if you have a contiguous vein of water that starts at the water table and ends at the bottom of your well point. In my case, I've got a 30-foot thick slice of water underground. What matters to that 25 feet limitation is where the top of that water is. The effective pumping height of my shallow well pump, even though my well point is 40 feet below ground, is only 10 feet. Think of it this way. Imagine you had a big swimming pool in your backyard that was 100 feet deep. You could hook up a shallow well pump with a 100-foot long pipe with a well point at the bottom sucking up water, and it would work just fine because that water begins at the surface. So the effective depth is 0 feet. LOL, one of them cone bits. Yeah, I called it a cone bit, okay? I know it's called a step bit. Actually, somebody thinks it's called a uni-bit. Never heard that one before. I call it a cone bit. Sue me. Next question, does it freeze in the winter? And the answer to this is basically yeah. But in my case, because I mainly use it to water my grass and do other stuff outside, I don't really use it in the winter anyway. I shut everything off and I drain the system when I think it's going to get much below 32 degrees Fahrenheit, and I won't have a problem as long as I remember to do that. Now, there are some solutions I've been considering so that I can use the well in the winter, or at least not have to drain it every year. One of those is a heated wire that kind of snakes around the plumbing and is supposed to keep everything nice and toasty when it's cold. I'll try that this winter and let you all know how it goes. Why don't you pound a steel pipe? Yeah, I have pounded a steel sand point before. It is much harder work than jetting a well. Not only is jetting easier, but if in the right soil conditions, you can get down a lot farther. Because when you're pounding that well point, you're basically just driving a big fat nail into the ground. And the deeper you go, the harder it is to drive because of the friction that builds up around the outside of the cylindrical walls of the pipe. It only grows the deeper you go. You can certainly drive a steel well point if you want, but it's a lot more work and you probably can't go as deep into the ground. Next question, very popular. What do you do if you hit a rock? Now, where I am, we don't have very rocky soil, but there are rocks in there. And I actually have hit a rock before when I was driving a steel sand point in one of my other videos. What happened there was when I hit the rock, it actually broke my well point. And I had to pull the entire thing back out of the hole in order to fix and replace it. So, what could happen if you hit a rock? That's what can happen. You can break your pipe. If it feels like you're hitting something really hard, don't keep just trying to press through it. You can break something. How did you know there was a vein right there? This is probably the most common question I get, and I actually addressed it in my previous video where I responded to some other comments. Here's the thing. It's not possible to know where water exactly is in advance, okay? If you could figure that out, you could make a lot of money selling that technology to oil companies, to companies mining for copper, natural gas, iron, nickel, cobalt, all other manner of natural resources that are hard to find. Can make a lot of money if you know exactly where they are in advance. Water is no different. Here's the problem. The technology just doesn't exist. That's why people resort to these astrological things like dowsing rods and other superstitious methods of thinking you can locate where the water is in the ground just by believing hard enough. Embrace the unknown. You don't need these little, what are the little coat hanger things? Come on. It's ridiculous. Fact is, the technology doesn't exist yet. You just have to start digging the hole, and you either hit water or you don't. Okay? It's a binary result. It's trial and error. Okay? And that's part of the fun. You don't know what you're gonna find when you start digging. And for me, that was the biggest learning experience. I had no idea what was 10 feet underground. There's so much interesting stuff down there. It's almost sucks the fun out of it to just know exactly where it is. Then it's not interesting. It's not a discovery. It's just work. Dig. If you hit water, start pumping it out. And if you don't, dig another hole somewhere. Or dig deeper. That's the only way. Okay, and now for the cost breakdown. When it comes to digging, here are all the parts. You need a bunch of 2-inch PVC, 40 feet in my case, a bunch of 1 1/4 PVC, that's the inner well pipe. You need a bunch of couplings and other fittings. You need 10 feet of the 4-inch PVC outer casing and the 5-foot PVC well point on the very bottom. Now, the cost of all that stuff put together is a little over $100. PVC is not that expensive. In my case, I didn't already have a pressure washer. So I had to spend $100 on the pressure washer and then another $48 on the 50-foot pressure washer hose that I used. As well as halfway through the project, I went out and bought a 1/4 horsepower transfer pump to pump all the sand and clay away from the hole and away from the side of my shed. So the total cost for digging the well, in my case, was $488. When it comes to the plumbing side of things, so getting a pump hooked up to it and drawing the water out of the hole, 10 feet of 3/4 inch and 10 feet of 1-inch PVC pipe. This is just to connect the pump to the yard hydrant and all that kind of stuff. I needed the yard hydrant, which itself was $67. The 1/2 horsepower well pump that I got was $220. That was the second one after I replaced the initial one I got that had that dent in it. The 7-gallon pressure tank, that's the big blue thing that the pump sits on top of, that was $177. Along with the check valve, a bunch of brass fittings, the sediment filter, that was $44, and a couple of water heater hose. Put it all together, and the plumbing side was $644. So combined, the digging section with the plumbing section, $1,132. That was the total cost of digging my 40-foot well, and now I have water forever.